Hello, this is a video for AP PreCalculus section 2.4, Exponential Function Manipulation. I am Coach Meidenbauer, and do not forget to like and subscribe, and let's get rocking and rolling here. This video will use a bit of Desmos as well to verify some stuff that's going on for some of these properties. None of these properties are new to us in terms of transitioning from Algebra 2 to PreCalculus. There's really not much new, maybe just the verification that we're going to use on Desmos. So we should really get through this pretty quickly. So let's get rocking and rolling here. So first thing we're going to talk about is the product property for exponents. If you are multiplying two exponents that have the same base, then you add the exponents, or multiplying two numbers that are both exponential that have the same base. I think I said that right the second time. So this is going to turn into 2 to the 3 plus 5, which is just 2 to the 8. Okay, I don't really feel like simplifying that. For letter B down here, we're going to get 2 to the x plus 5. Same base, add the exponents. For letter C here, we don't have the same base, so there is nothing we can do other than rewrite the numbers so they happen to have the same base. Is there a way I can get 16 to have a base of 2? Of course there is. This is going to become 2 to the 4 times 2 to the 6. Same base, add the exponent, so you're going to get 2 to the 10. Last one here for this product property is if we have 4 times 2, same thing as 2 to the 2 times 2 to the x, which equals 2 to the 2 plus x. All right, now let's gonna get down here. This example is really more of just a sit and get, and not really much to write here. We're gonna be given, right here is 2 to the x, and I'll graph that in a second here. Graphically, every horizontal translation is equivalent to a vertical dilation within exponentials here. So we're gonna graph g of x in just a second, and by translating the graph left 2 units, so we're gonna take 2 to the x and move it left 2 units. And we're also going to graph 4 times 2 to the x, which is going to be a vertical dilation. So let's go ahead and get to that. All right, so we are first given f of x is 2 to the x. Okay, that's in purple. Okay, so that's in purple. We have g of x, all right, which is going to be 2 to the x. I hate how Desmos does this. I'm going to write it this way. It's easier for me. Why did I do 5? It should be 2. Okay, so if you notice, every single point here on purple moved left 2. Okay, we agree everything moved left 2. You can see the space in between here. Everything moved over 2 units. Now, h of x here is going to be represented by 4 times 2 to the x. If you notice, I'm going to actually undo the red one there. If you notice, it overlaps the black one right there. So I'm going to kind of get rid of everything right here. So if I just have 4 times 2 to the x, all these values right here just get multiplied by 4. So this number gets multiplied by 4. This number right down here by -2, which is 1/4, gets multiplied by 4 to become 1. This value right here at 1 multiplied by 4, that becomes 8. You can see that as I go out from this a bit here. That's no different than shifting the entire graph left 2. So that's all that example is just kind of getting you to visualize that for exponentials, vertical dilations can very easily be a horizontal translation. Okay. So getting back to the notes here, let's do the power property. So for the power property here, all we're doing is, since we have a power on top of a power here, we're just going to multiply. So we have, for this first one, we have 5 to the 3 times 6, because it's power on power. Multiply that, and we're going to get 5 to the 18. For letter B, same thing. Multiply on top. We're going to get 2 to the 5x. Example 2 down here, we're going to do the same thing, except we're actually going to rewrite. We're going to flip a bit here to have a different base. So we're going to do 3 to the 5x, just as we did for part B beforehand. But now we can state that this is 3 to the 5th all to the x. What's 3 to the 5th? I don't know either. 343? 243. 243. To the x. Next one here, same exact idea. It's just gonna be, this is gonna become 2 to the 5x, which we can rewrite as 2 to the 5th to the x, which becomes 32 to the x. Negative exponent property. All this is a negative exponent becomes the denominator inside of a fraction, so as you can see in that property right there. So if I had to rewrite 2 to the negative 3, it's the same thing as 1 over 2 cubed. Okay, which by the way is 1/8. So the negative 3 does not make the number negative. It just shrinks it. So we go from 2 all the way to 1/8. Well, I don't want to see it always shrinks it, but since this base is positive, it's going to shrink it. They're not positive. This is the base is bigger than 1. Okay, this next one becomes 1 over 3 to the 4th, which is going to become 1 over 81. Super simple. Another example here, I'm just going to show you on Desmos here in a second. So we're again given 2 to the x, and we're going to kind of show you the similarities between a horizontal dilation of a factor 2 and how it can be equated to being a 4 to the x. So I'll delete these over here. So f of x is still the same from my previous question here. Now I have g to the x, which is going to be 2 to the 2x. You can see 2 to the 2x is going to grow a little bit faster than 2 to the x. Oh, there we go. I'm just trying to drag this. There we go. And then if I write 4 to the x and give that a color, it's going to overlap the 2 to the 2x from the previous examples that we just did. All right, let's wrap this thing up here. Oh, thank you that you saved to my drive. Last thing here is just rewriting with exponentials that are fractions, how to rewrite them really as radicals. So all you do here is you just take this 3 right here and place that in front of the 8. So this would become cubed root of 8 to the first power. Because of that 1 right there, it still makes it a first power. So, which is the cubed root of 8. Anybody know the cubed root of 8? Very good, it's 2. Next one, take that 4, move it out front. This is going to become the 4th root of 81. Does anybody know the 4th root of 81? Just did that on part B from previously. It's 3. That's going to wrap up our video here. Like and subscribe.